The human lineages referred to as distinct biological species, including Neanderthals, Homo heidelbergensis and Homo sapiens, are in fact not so. They're just referred to based on morphology and cultural factors. Because biological species is defined as a group that can interbreed to produce fertile offspring over endless generations, this clearly doesn't fit the bill, as we have had fertile offspring with Neanderthals, Denisovans, and another group, which is likely to be a descendant of Homo erectus. However, one caveat when going into deep time is that there are no clean transitions. The parent cannot be infertile to the offspring, except perhaps for in the time of the chromosome 2 fusion. Sure, the geographical isolation occurs, and after a long time in many species, this leads to true species divergence, what we call speciation, where fertility ends at a few generations, such as for lions and leopards with 2 to 3 million years of divergence. But the process is continual. We only see after 2 to 3 million years that this divergence becomes speciation. At 100,000 years after isolation, it's very unlikely that this would happen among humans. How about 500,000? How about 1 million? There would theoretically be one point where they could no longer have endless fertile generations, or what I call EFG, and this point would be the speciation point. In reality, this would have likely been quite different in different individuals. A species is not a linear progression, but it's a hodgepodge of individuals with different genetics, with gene flow, so a common gene pool. So the speciation point may not be one, but it would be multiple, depending on the specific race of species or subspecies and the affinity to different races within that. To give an example, Homo habilis at 2.5 million years ago is unlikely to interbreed with Homo sapiens. However, it would be more likely to interbreed with the Homo erectus just 500,000 years later, or maybe even a million years later. However, the Homo erectus would be able to interbreed with sapiens, so the Homo erectus can do it with both, whereas Homo habilis and sapiens could not. Now, the reasoning for this is simply because of genetic divergence. So, if we understand with this example, the placement of where a species begins and a species ends is continual and even infinite, because it just depends on where you're looking from and what the current present time is. So our definition of Homo sapiens is just based on us at the current moment. If we were living 300,000 years ago as Homo sapiens, it's very likely we would define our species based on the individuals we could interbreed with at that point, going back in time, which may even be a million years before or even 2 million years before. We already know that Neanderthals, Denisovans, and Sapiens are the same species, as we carry their DNA to this day. Another group, which diverged 2 million years ago and spread across Eurasia, had endless fertile generations with us. There is no other group that could fit this than Homo erectus. The evidence for this is in West Africa, a ghost population, which they estimate diverged around 1 to 2 million years ago. And we carry their DNA to this day, so the two did not have true speciation. If the two did not have true speciation, as we have clearly had endless fertile generations since then, as the West Africans currently hold up to 20%, with estimates some being lower, then Homo erectus is Homo sapiens. This is caveated by some uncertainty, as some will say the DNA came from Neandersovans who had interbred before. But first of all, this is unlikely, particularly as it's most common among African populations who generally do not have Neandersovan DNA. But the second part to this is that even if that were so, it's very likely that all were the same species regardless. These subspecies were historically classified as separate in the pre-genetic era. It is time for us to classify them all as lineages of one species, Homo sapiens, as is biologically accurate. Cultural and morphological understandings of species follow from biologically true definitions and not the other way round. In reality, this transition would have gone from Australopithecus africanus around 4 million years ago And according to this estimate, if we make it all for all of the individuals that are of the same species, which is defined by having endless fertile generations, and this would be from 4 million years ago to 2 million years ago, then Homo habilis would be from around 2.5 million years ago to 1.5 million years ago, encompassing all of the individuals within that can interbreed with each other. And Homo sapiens would be from 2 million years ago to the present day. With the overlap present within that, it would show that Homo sapiens and Australopithecus africanus could never interbreed. However, Homo habilis at some point could interbreed with Australopithecus and with Homo sapiens. The reason why Homo sapiens would be back to 2 million years ago is because we currently classify ourselves as Homo sapiens. If this is the case, we have to reach for the furthest individual genetically who would still be able to interbreed with us. And based on the evidence in West Africa from the ghost DNA population, this appears to be around 1 to 2 million years ago. The nature of speciation is that there must always be a transitional species that is fully interfertile with both the ancestral and descendant population, while each are only fully interfertile with the transitional population and not each other. This is best exemplified by the example of Australopithecus africanus transitioning into Homo habilis, that's the transitional species, and then into Homo sapiens.